Welcome to the class. This is our usual time. So, as far as Plant Health 108 is concerned, we have two major goals. The first of which is to provide students with an overview of the theoretical principles and the applied methodology of integrated pest management. So the main reason we're going about this process is essentially that IPM is an applied methodology. It takes place in the field. IPM is a practical skill. So it's useful to have an idea of what are the techniques that we use and have a little bit of hands-on practice doing that. So that's going to be mostly the purview of the lab. We're going to try and get out into the field as much as we can during lab to learn these sorts of things. As far as theoretical principles are concerned, this is arguably the most important part of IPM, because the reality is that there's no instruction manual on how to do pest control. There's a ton of resources through the UC IPM, from other PCAs, from things like that. But the reality is that at some point you're going to come across something that you've never seen before. And having a good theoretical understanding of how pests work, how agroecosystems work, is going to be your best tool in figuring out what to do and to provide all sorts of good services to people who employ you. So there's always understudied crops, new pests. There's always jerks across the road who don't take as good a care of their fields as you are, and their stuff is flying across and getting in to you. So it's always good to have a little bit of a good basic understanding of what's going on. Second major goal is that we are training you to take the IPM section of the Department of Pesticide Regulation PCA licensure examination, which is a mouthful. But how many of you intend on taking the PCA exam? A fair chunk. Now, not all of you plan on being PCAs. I understand that. But at the same time, I know a PCA license is important for a lot of jobs in agriculture here in California. So to get that, you have to take 3 exams, right? Regulations, IPM, and the specific topic exams. So this course is designed to help you learn those, to specifically the IPM section. So before we get started with IPM, let's talk real quickly about what Plant Health 108 is not. Plant Health 108 is not economic entomology 2. IPM was largely invented by entomologists. It is kind of a point of pride in the entomology community that we basically came up with the paradigm that everybody uses for pest control now, which was exciting. And I will be talking about a lot of insect examples because a lot of the things we do in IPM apply to insects and don't necessarily apply as well to pathogens and the like. That being said, we don't have another insect collection. So, yes, yay! That being said, the insect collections last semester were pretty awesome. So it was nice to look at them, but I will appreciate not having to take 5 days to grade them all again. This is not a review of agricultural pests. I'm not going to go about teaching you what an insect is, what a pathogen is, all of that again. By virtue of being here, that means you took an entomology course, whether it was my course, Dr. Gonzalez's, or some other one. Excuse me. And you've probably also taken at least one of these other ones, whether it's plant pathology or weed science or something. So you have a good idea of what pests are. You have a good idea of what the basic control techniques are in those areas. I'm not going to go over that in great gobs of detail. The purpose of this class is to basically take all of those things and show how they overlap with one another and how we can provide control across platforms to sort of have a holistic system. And finally, Plant Health 108 and IPM in general is not a political agenda or an environmentalist agenda. And a lot of you may be saying, of course it isn't. But every time I teach this course, in one of the early quizzes or exams, I'll have some question that says something like, give me a definition of IPM, or, suggest an IPM regimen for this particular crop. And I'll get some answer that, I'll never stop spraying pesticides, environmentalist hippie. And as much as I love those answers, I kind of just want to head that off right now and just say that IPM is not the same thing as organic agriculture. At the same time, it's not the same thing as spray and pray. It is its whole own thing. The goal of IPM is to benefit all agricultural stakeholders, whether they're growers, whether they are consumers, whether they're people who live in agricultural areas but aren't necessarily agricultural themselves. The purpose of IPM is to provide nice environmentally and economically stable control and to reduce risk in the ecosystem and in agriculture generally. And so my goal here isn't to basically say you should never spray pesticides. It's not to basically say that everybody's doing everything wrong. Just here to teach you how IPM works and ideally what the benefits are of IPM and why you should be implementing it as professionals in agriculture. So what is IPM? Now that we've gone over what IPM is not, and specifically what this class is not. So who can give me a definition of IPM?
Science-based decision-making system.
Okay, so we've got that IPM is science-based. And it is a decision-making system. What else would people like to add to this?
It's when you utilize different techniques to control something.
Okay, so there's multiple techniques.
It's long-term pest prevention.
Long-term. This is where we find out who downloaded the presentation before class started. All right, it's long-term. Anything else?
Ecosystem-based.
Yeah, some people definitely got it. Okay. So normally, as people in economic entomology can attest, normally what I do is I will post the presentations before class or shortly thereafter, but they will be missing information, like they won't have definitions listed on them. So you'll have to fill them out by either listening to a recording of the lecture or coming to the actual lecture. Since none of you had been told that beforehand for this class, I posted one with full information this week. Don't get used to that. So anything else? I think that's pretty good. Obviously someone was looking over, so that's good. So as you can see, IPM is a lot of things. It means a lot of different things to different people. There was a survey done back in the early 2000s where basically someone went through a ton of IPM textbooks, IPM articles, talked to IPM professionals, and asked them to give their definitions, and they took those definitions and broke them down by what they had in them, whether they had environment, ecosystem, multiple techniques, economics, things like that in them, and basically broke down what percentage of definitions had what bits. And basically they found that IPM definitions are all over the board. Some people see it primarily as an economic tool, some people see it primarily as a decision-making tool, and so IPM means a lot of different things to different people. And that's why you get some situations where I have people busting my chops over a test question because IPM means something different to them than it does to me. So with that, I think it's helpful to be on the same page and to have a basic class definition that we will be working with for the rest of the semester. And that's this one. I like Marcus Kogan's definition from 1998, where he says that IPM is a decision support system, for the selection and use of pest control tactics singly or harmoniously coordinated into a management strategy. This is based on cost-benefit analyses that take into account the interests and impacts of producers, society, and the environment. And I like this definition because it kind of pulls everything in together very succinctly. On one hand, IPM is a decision support system. So IPM is a set of steps that we use to reach a decision about pest management. Focus primarily on pest control tactics. It talks about how you can use single controls, but you can also use them harmoniously, working together. And it's also about cost-benefit analyses. The goal of IPM is to maximize the benefits that everybody gets. Whether you're the grower and you're trying to get the largest yield at the lowest possible cost, whether you are someone in society who's purchasing this food, who wants food that is safe and ideally has the lowest amount of pesticide residues possible, or if you're someone who's interested in the environment and is interested in maintaining wildlife and protecting water quality. So IPM, Decision Support Network, all about making, basically coordinating pest control tactics to maximize benefits for everyone. Oh, it's me. All right, so let's touch on sort of the major parts of this. IPM is a science-based decision-making system, right? And oftentimes it's broken down into sort of somewhere between 3 and 5 steps. This is the system that the book likes to focus on, stepping through identifying all the way to evaluating the results. I tend to lump things up a little bit together. And I like to think of these as a series of questions that we can ask when we're working in the field. First of which being, do I have a pest problem? Which primarily focuses on this idea of, well, we need to know what pests are. We need to be able to know what it is that we're looking at, whether we are making a correct identification, making sure we don't have the wrong organism, as well as monitoring those pest populations once we know what's there. So when are pest populations growing? When are they shrinking? When is the ideal time to treat? When are they going to be the most danger to the crop because it's in the stage where the crop takes the most damage? After which, we have the question of whether or not we should apply management, right? Sort of this assessment step. For every pest species that we have at a site, are they at the proper threshold? Are the plants in danger? Should we actually make that treatment? And then finally getting into this question of how do we apply pest management in the best possible way? Specifically in a way that's economic to growers, so that growers aren't losing money on a treatment, but at the same time is sustainable for the environment and is safe for human health to the consumers, to the appliers, to the people who have to live in the area. So sort of that implementation step. And then finally, there's also a little bit of an IPM question for people who like to ask this question, do our current techniques work well enough, right? Sometimes you're doing something because you've been doing it for a long time, and maybe it's not the most economic, maybe it's not the most effective. At the same time, you've got things like pyrethroids that have been around for a long time. We've been spraying them all over for lepidopteran control, and now we're starting to see resistance. So maybe it's asking this question of, is our IPM working? Do we need to develop new tools? Do we need to talk to people and figure out what to do? And so that's sort of the final step, and that's something we will cover, especially in lab, is how do we investigate whether things work. So IPM has an ecological perspective, sort of that ecosystem-based scribble on the board over there. That essentially, the idea is that we're focused on long-term control by not just managing the pest species specifically, but by managing the entire ecosystem. We want to manipulate fields in such a way that they provide the maximum control. So we do this through things like habitat modification that we talked about in economic entomology as sort of ecological control or cultural control. So basically, using Liebig's law to reduce carrying capacity, we want to identify what are the most important things to a pest population and then remove those from the ecosystem. Basically, take away the ground they're standing on so that those populations are driven down. But we also want to maintain field conditions that favor natural enemies of pests, so that essentially we have more biological pressure on them, pushing those populations down. And then finally, the idea that pesticides are allowed to be used. Pesticides are a powerful tool. We can't really grow food in such huge amounts as we do now without the use of pesticides, but that pesticides at the same time shouldn't be used ahead of time, but really should be used prescriptively. Used in a situation where you have economic damage coming down the road, or you expect there will be damage, and you want to head off a problem before it gets there. I suppose lastly, the other thing is, we want to also keep in mind that we're not just dealing with the pest ecosystem, we're dealing with the crops ecosystem. So any change that we make in these 3 areas needs to not only minimize the quality of the environment for the pest, but also needs to maximize the quality for the crop. So it's a really delicate balance. How do we build ecosystems that benefit crops but hurt pests? So, just want to do a real quick exercise at getting an idea of what is IPM. So, you could turn to a neighbor, maybe groups of, as 3 or 4 if you'd like, and just go over these 3 hypothetical situations. And just would like you to come up with an idea of whether you think these qualify as IPM or not. Give you, 3 or 4 minutes just to go over them.
So it's like preventative.
Is it all right? Sure, so, yeah, so it's not about us.
Probably not. It's not in response to anything, it's purely preventative. And he doesn't even know if he has a problem.
Yeah.
Yeah, definitely. It's better than gender.
Oh yeah.
Today, what you probably do is prepare, put the cup and screen on.
So we take over and say, right now, and we take for the
I know, right? Less than me.
better living.
Yes.
In this case, we have to take the
I gotta do the right side. But I mean, like, it smells like you're so hard. We stay all the time. I like that.
If there was given more context,
No,
content's given.
All right. Sounds like we transitioned from talking about this to talking about other things. So let's start. Let's start with the third one. Would you say that this counts as a integrated pest management solution? Why?
Well, they're thinking long-term. The resistant rootstock is a long-term solution.
All right, so they're using multiple tactics. They're thinking long-term, right? Because they've got this resistant rootstock, which is always handy. So that's something that's obviously a very long-term investment. So they're looking ahead to that. Yeah, they've got the resistant rootstock. They've got the cover crop. They are trying to preserve natural enemies. They're monitoring. So lots of tactics looking at this pest situation. Anything else?
They're creating a habitat to preserve natural enemies.
Okay, right. Yeah, they're sort of manipulating the ecosystem, trying to create a habitat. All right. Yeah, so that one seems pretty clearly to check a lot of the boxes for IPM, what we would consider an IPM system. How about this second one? Would we consider that IPM?
Yeah.
I'm hearing a yeah, but a lot of people not saying anything.
I would say yes, because you're close to the economic threshold, meaning that, well, if you did anything prior to this, it's not working. So using a systemic insecticide is like the last step.
Mm-hmm. Okay, so we've got an economic threshold, we've got a systemic. So it doesn't tell us a whole lot about anything they were doing before. But at the very least, we know that they were monitoring. So they were out there looking for the pests. They were trying to figure out whether they had a pest problem. And they also knew enough about the pest biology and how the pest affects the crop that they were using something like a threshold, right? So they weren't just out there looking at aphids going, boy, that's a lot of aphids. You know, they were saying, that's a lot of aphids, and they're about to start causing economic damage. So we've got two things going on there. Anybody else? Anyone feel that maybe this isn't IPM? Okay, anybody else for why this might be IPM?
You're protecting natural enemies.
All right, you are protecting natural enemies. So that kind of gets to the idea again of manipulating the ecosystem to a slight extent. That if you are going to spray a pesticide, which by definition kills pests, kills insects in this case, you can at least apply one that is targeted and will go after the pests rather than your natural enemies that are out there providing control. So you could almost consider that to be something like conservation biocontrol, which would fall under multiple tactics, right? So you could think of it that way. How about this top one, the almond grower with the fungicide? Is that IPM?
Absolutely not.
No. Why not?
Well, you can't really use a fungicide as a preventative measure. And if you spray it the wrong part of the season, you're going to have a worse problem later on.
Okay.
And he's spraying too early.
Okay, so it sounds like fungicides, can't be preventative. Timing might be key as well.
And
Anything else?
we don't know what else he did to prevent this problem. How sanitary is his orchard floor? That's not stated. That's where a lot of the rust overwinters on the hulls of the almonds.
Mm-hmm.
So are they mummies in the trees? Are they knocked off? Are they mummies on the ground? Or
Right, so there's lots of questions here. We could assume that if I didn't mention it, that they probably weren't doing sanitation, or maybe they were. It doesn't really matter in terms of this particular decision, though. I guess I'm asking more so if this decision is IPM. It's not.
There's no monitoring involved, right?
no?
All right. So it sounds like we feel that we have something of a bit of a gradient here, something that's very clearly IPM, something that seems like it isn't IPM, and something that falls somewhere in the middle, that maybe it's implementing some IPM tactics and some that aren't. Well, that brings me to my next point, which is the idea that IPM is a spectrum. And in reality, you could make the argument that each and every one of these is IPM, even the top one. Technically, you can spray Manab at the sort of petal drop. It's not necessarily the most effective, but according to UC IPM, it is a good IPM decision to apply Manab based off of previous year's rust problems. They consider that a form of monitoring. This would basically be the lowest possible rung on the IPM ladder, is the idea. And so, essentially, IPM can differ based on how biological or labor-intensive the various processes that you do are. On one end, sort of the least intensive, you've got things basically based off of scouting, using past reports, economic thresholds, GMOs, resistant crop varieties, things that involve very little input and that look like the stuff that basically most everybody is already doing, right? But technically, those are IPM. It's a heck of a lot better than what we were doing 40, 50 years ago, where people basically went out and if they saw an insect or a fungus or something, they would just go out and spray. That these are already considered IPM. And then you can move all the way up to the very most intensive. Basically things that involve like altering the habitat for biocontrol. They've got these things called beetle banks, where essentially you would take a strip in your field and you just hump up the dirt and grow a bunch of wild plants on it to protect beetles. And that's essentially taking 2 or 3% of your field and saying, I'm not going to make any profit off of that. And so that's very intensive. That's a big money sink. That's a big investment. Things like intercropping, push-pull, polycropping, area-wide programs would be considered very intensive IPM. And then there's a ton of stuff that falls in the middle. And so the basic idea is that the correct amount of intensity is very specific to the system that you're working in. It depends on the grower, what the grower's resources are. It depends on the crop. Is there a whole lot of IPM known about the crop? Are there lots of different tactics? Or are you working with something that basically the only form of control is spraying pesticides? Locations, pests, economic constraints, market forces, all of these things can determine where you fall on this spectrum. And I was talking to Jim Farrar the other day. He's the head of the University of California's IPM system, and he used to be the plant pathology professor here before Dr. Ellis took the position. So Fresno State people in high places. But he was saying that basically in his mind, he doesn't care if you're all the way at the least intensive or if you're all the way at the most intensive. What he cares about is that people are doing IPM, and then at the very least they're going out and scouting and are making decisions based off of information. And so where you fall is really going to depend on the system and the idea that there isn't one right answer. There's a lot of decision making that will be in your hands and in the hands of the growers. All right. So that's my blurb on what IPM is, just trying to sort of set the tone for the rest of the course and where we're going to be going and how we'll be talking about IPM. So as far as the actual course is concerned, the basic idea is that this is supposed to be a broad introduction to IPM with a focus on the ecological perspective, balancing competing interests. So, when we have a situation where we're maybe taking a trade-off between environmental quality and economics, how do we make decisions based around that? And then also IPM as the decision-making process. So as far as the textbook is concerned, we've got two of them. One is required, one is supplemental. The required one is IPM in Practice by Flint. So this book is great. It's maybe a little overly simple, but the nice thing about it is that this is the official study guide published by the UC system for the DPR PCA exam. And so when you take the IPM section of the test, they use all the definitions from this book. So if you're planning on taking the exam, you should purchase this book. Consequently, if you're taking this class, you should purchase this book. And it's only like $30. So it's pretty reasonable. You can get it, I think I checked at the bookstore, and they sell it for the same price the UC does, which is that $30 to $35 price point. And I don't think you'll find it a whole lot cheaper than that anywhere else. The other book is this guy, Entomology and Pest Management. You may recognize this. This is the textbook we used in economic entomology. And so we will be touching on topics from this when we want a little more detail on something. So hope you held on to that book. I think I warned you at the end of the last class that we will be holding on to it for IPM. Yeah, and there may be additional readings. They will be posted online. I just said that. All right, lectures. You're here, so you know when lecture is. That's great. It's Tuesday, Thursday, and then we've got lab more or less immediately following at 2 o'clock. So I hope you're ready to dedicate your entire afternoon to IPM for the foreseeable future. But lab will be, as was said earlier, over in 119. Same lab we had economic entomology in. It's just right down on the first floor by the stairwell. So the lecture order. Lecture is approximately going to follow the IPM decision-making process. So we're going to basically address every step in that decision-making process as a series of lectures. So consequently, we'll be starting out at this idea of understanding what pests are and when to identify that there are problems. We'll then shift down to steps 2 and 3, the idea of how do we monitor, establish thresholds, when it is it that we actually should be treating. Finally, we'll bump down to implementation. So what are the major tactics that we use in pest control, whether that's biocontrol, cultural, have a little section on genetic controls, looking at some of the new tools that we have based on DNA, RNA technology. And then finally bumping down to how do we evaluate success, and also looking at sort of the practical aspects of IPM. Where does IPM work? Where does IPM break down? And what can we do with that?